Hello everyone, my name is Nikita Shetty and I am from Aeronautical Department. My roll number is 08 for Industrial Management and Operation Research subject. So I am going to explain about transportation model and I am going to give some example about this. So let's start. So first we have to know what is transportation model. Transportation model is intended for finding least cost route. So a company has M plants and N warehouse at various places. So a product manufactured at company's plant required to be shipped to warehouses. The transport cost from each plant to each warehouse, which is a function of distance that is known. So the objective of the transportation model is to find out least cost route for plant to warehouse and hence to increase the profit. So what is the procedure to solve the transportation model? There are some procedures. What are those? Then first we have to make the transportation model. After that we have to make we have to find what is the basic feasible solution for the transportation model. After that, uh, after finding that basic feasible solution, we have to perform the optimality test. After that, we have to iterate that towards the optimal solution and we have to check for the optimality. Let's see about definition. Feasible solution. A feasible solution to a transportation model is a set of non-negative allocations. Xij satisfies the row and column restrictions. Basic feasible solution. A feasible solution to a transportation problem is said to be basic feasible solution if it contains no more than m plus n minus 1 non-negative allocations. Then m is number of rows and n is number of columns. After that, what is the optimal solution? A feasible minimizes means we have to minimize the transportation cost and maximize means we have to maximize the profit. That is the optimal solution for the transportation model. Then what are the methods for initial basic feasible solution? First is northwest corner method, row minima, column minima, least cost method and Vogel approximation method. So let's see the first method, northwest corner method. The northwest corner rule is a method of computing a basic feasible solution of a transportation model where the basic variables are selected from the northwest corner, that is from the top left corner. The standard instructions for a transportation model are paraphrased below. You can see there. So what are the steps in northwest corner rule? First step is we have to select the upper left hand corner cell of the transportation table and allocate as many units as possible equal to the minimum between available supply and demand. Adjust the supply and demand numbers in the respective rows and columns. After that, if the demand for the first cell is satisfied, then move horizontally to the next cell in the second column. If the supply for the first row is exhausted, then move down to the first cell in the second row. If for any cell supply equals demand, then the next allocation can made in cell either in the next row or next column. So continue the process until all supplies and demands values are exhausted. So let's take an example for northwest corner rule. Here is a problem given. A Amulya milk company has three plants located throughout a state which with production capacity 50, 75 and 25 gallons. Each day the firm must furnish its four retail shop R1, R2, R3 and R4 with at least 20, 20, 50 and 60 gallons respectively. The transportation cost in the rupees is given below. You can see here in this table. So demand they have given 20, 20, 50 and 60. The supply also they have provided us that 50, 75 and 25. So for the plant R1, R2, R3 and R4 they have given the production. So let's see. In this table, the economic problem is to distribute the available product to different retail shop in such a way that so that the total transportation cost is minimum. Starting from the northwest corner rule, we allocate 50-20 to PIRI, that is 20 cells, 20 unit to sell PIR1. The demand for the first column is satisfied. After that, we have to move horizontally to the second column in the first row and allocate 20 cells to PIR1, PIR2. The demand for the second column is also satisfied. So after proceeding in this way, we observe that P1R3 is equal to 10, P2R3 is equal to 40, and P2R P2R4 is equal to 35, P3R4 is equal to 25. The resulting feasible solution is given in the following table. So here is the solution, and for that solution the initial basic feasible solution is given as the total transportation cost is calculated by multiplying each xij in an occupied cell with the corresponding cij and adding as follows as 2x3 20x3 plus 20x5 plus 10x7 plus 40 into 8 plus 35x2 plus 25x2, that equals to 670. So for this problem the solution is 670. We will move towards the next type of transportation model, that is Vogel approximation method. The Vogel approximation method, that is unit cost penalty method, is an iterative procedure for computing a feasible solution of a transportation problem. This method is preferred over the two methods discussed in the previous section as in the second slide. So, because the initial basic feasible solution obtained by this method is either optimal or very close to the optimal solution. So, what are the steps in the Vogel approximation method, that is VAM? First we have to identify the boxes having minimum and next to minimum transportation cost in each row and write the difference, that is penalty, along the side of the tables against the corresponding row. What is the second step? We have to identify the boxes having minimum and next to the minimum transportation cost in each column and write the difference, that is penalty, against it. What is the third step? We have to identify the maximum penalty. If it is along the side of the table, we have to make maximum allotment to the box having minimum cost of transportation in that row, and if it is below the table, we have to make maximum allotment to the table minimum cost of transportation in that column. So what is the fourth step? If the penalty is corresponding to the two or more rows or columns that are equal, we have that liberty to break that tie arbitrarily. So after that we have to repeat that above steps until we are all all the restrictions were satisfied. So thank you.